Well, the most important news that we have to share with the world is that planetary systems appear to be quite common, and that systems of multiple planets in configurations that are similar to those of the solar system appear to be quite common as well. Nearly 1 in 5 of the candidates stars has multiple transiting planets, and that's something that's a complete surprise to us to have this result out so soon, so early in the mission. And of course, the breadth and diversity of the discoveries in terms of the size of the planets and their distribution across the field of view is also very important. It looks like nature really loves to make planetary systems.
And I guess as for the media and the public, the interest in these planets which are in the habitable zone and going closer and closer to an Earth-like planet, that's the most interesting stuff for us. So what can you say about these over 50 planets in the habitable zone?
Well, what we can say is that they, at this moment, are candidates. They still require follow-up and vetting before we can confirm the planetary nature of the signatures we've identified in the data. But all indications are green that they are planets to date. We just simply have to do our homework and make sure that we haven't made a mistake. We do believe that only a small fraction, 20-25% of the candidates we've identified will in the end turn out not to be planets, and that the vast majority will in the end be planets. But when it comes to planets in the habitable zone, we're going to be extremely cautious because that is the primary goal of the mission, to identify planets in the habitable zones of sun-like stars. So we'll all have to be a little bit patient before we can actually call these things planets. But it's really thrilling to see such a large number of planets candidates in the habitable zones of their stars so early. Now, most of these stars are smaller than the sun, cooler and dimmer, and so that's why the shorter period orbits that we can discover with only 120 days worth of data allow us to discover candidates in the habitable zones of these stars. So I would not call these planets, if they prove to be planets, Earth-like, even if they're Earth-size, because their sun's totally different. So you can imagine that you would need, if you had plants on those stars, they would be looking at far redder light than we experience here on Earth, so the plants would have to be different. Of course, Kepler won't be able to tell whether there's life on these planets. That will have to be left to succeeding generations of telescopes and scientists and astronomers in order to determine whether there's life on these planets. But what Kepler does is provides us with a census of planets, whether they're in the habitable zone or not, across the full spectrum of stellar types that are in the neighborhood of our galaxy. And so this sets the stage for succeeding missions like JWST and like TPF, Terrestrial Planet Finder, whose primary purpose will be to follow up and characterize planets in much more detail, and we'll look for biomarkers, chemical signatures in the atmospheres of these planets that are indicative of life existing on those planets. And that's something that we should expect to see in the next several decades.
When do you expect to check up these? I mean, if we talk about the 5 smallest of these candidates in the habitable zone, when will you check them up, and when will you be able to tell a bit more about them?
Well, we won't be able to start following up these candidates again until about April, when Cygnus rises in the night sky, so that we can actually observe it with telescopes from the ground. And so as soon as we get time on telescopes and Cygnus is up in the sky, we'll be following up these candidates, putting every resource available, especially on the smallest planets in the habitable zones of these stars. So I expect the 50 candidates that we've announced today, they'll receive a lot of attention. I think just about everyone, including some of our software developers, who they themselves are amateur astronomers, will be going into their backyards to point their telescopes at these targets.
And the last key question, when will you be able to push this thing the key step further and find those really Earth-like analogs out there?
Well, come back 2 years from now and ask me the same question, because all we need is time. Kepler is flying, it's performing beautifully, we're getting great data, it's just exceeding everyone's expectations in terms of the quality of the data and the phenomenal scientific discoveries that are being made. Not just extrasolar planets, but other astrophysical fields are being revolutionized by Kepler, and we simply need to have a sufficient amount of time to see at least 3 transits of an Earth-sized planet in the habitable zone of a sun-like star to then say we need to put our follow-up observers on this to confirm the planetary nature of it. And so it'll take about 3 years of the mission before we can identify such planets in the data, and then several months of observing thereafter. So I expect in the 4th year of this mission that we have the first real chance of discovering and announcing true Earth analog planets in the habitable zones of their sun-like stars.